Question 5. Integrate this expression with respect to x. First thing to do is to try to factorise the denominator. Having tried various methods, it becomes clear that there is no easy way to factorise this denominator, so we need to do it by completing the square. If you can't remember how to complete the square, have a look at this reference. It's really quite good. This term here is b over 2, and this term here is b over 2 squared. 10 minus 9 is 1, so we can write the denominator as x minus 3 squared plus 1. Now what do we do with this? Well, let me remind you that sine squared x plus cos squared x is equal to 1, and if I divide throughout by cos squared, sine squared over cos squared is equal to tan squared, cos squared over cos squared is equal to 1, and 1 over cos squared is equal to sec squared, which is there. So let tan u equal x minus 3, so this becomes tan squared plus 1, and we differentiate this, so sec squared u du, which is the differential of this, is equal to dx, which is what we've got there. So if we put all this together, the integral now is equal to sec squared u du from here, that's the dx term, and then we've got the denominator, which is this term here, which is tan squared u plus 1. Tan squared u plus 1, as we know, is equal to sec squared, so that means this sec squared and that tan squared u will cancel, leaving us with just du. Integrating du, we get u plus a constant. Now tan u is equal to x minus 3, so u is equal to arctan of x minus 3 plus a constant. And if you got that far, you deserve the 5 marks. Okay, part B, we've got to integrate 5x times sine 3x. Remember from differentiation that the differential of u and v, where u and v are factors of x, is equal to u dv dx plus v du dx. So rearranging it like this, I can say that the integral of u dv dx is equal to uv minus v du dx. So if we let u equal 5x and dv equal sine 3x, so that gives us this expression here. That means that du is equal to 5 dx and v is equal to minus cos 3x over 3. When you do something like this, always differentiate it to make sure you get back to where you started from. The differential of cos x is equal to minus sine, and the differential of cos 3x is equal to minus sine over 3x, so that would get us back to there. Okay, putting all that back together again, we've got I is equal to uv, so there's the u and there's the v, minus v du. So v is there and du is there, so that's where that term comes from. Now the first term is a constant, so we can just write that down. The second term, minus 5 and 3, are constants, so we can take those out of the integration sign, so we're just going to integrate cos 3x dx, which gives us sine 3x dx. Now let's just be a bit careful about the signs here. We've got a minus here and a minus here, so that gives us a plus, and the integral of cos will give us a sine, so we end up with a plus sign here. Okay, finally we'll take 5 over 3 outside a bracket, and I'll just put these terms the other way around, so we've taken 5 over 3 out of that, which means we're left with a 3 there, so sine 3x minus x cos x. And don't forget the constant of integration, and that's our final answer.